Hello everyone, it's been quite a while since I was able to record a tutorial. Thanks for your patience if you've subscribed to my YouTube channel and haven't seen anything for quite a while. I wanted to jump back in with this quick breakdown of this stylized dissolve that I've created. Let me pull up a reference for the look that I was after, and then I'll jump right in and start talking through how this was built. This artist does a lot of really amazing cell animation, and I stumbled across this on my Twitter feed and thought it was fantastic, and immediately wanted to try to figure out a way to build this sort of dissolving edge into these like gloopy bubble forms. So let's talk about how I approached that. So here we are in Houdini. This is my node. This is my network setup for this effect. Everything's in here. I think for this video, what I am going to do is I'm going to give a very quick overview that will sort of explain the thought process behind this, and not go into very much detail. Not a step-by-step explanation of this network setup. The reason being, I don't want more advanced users who may be checking this out just to see how this was built really quick. I don't want to go into a ton of detail that's going to be redundant for them, so I'm going to breeze through it really quickly, and then after the fact, after I get through that, I'm going to drop down a new geometry SOP and build this thing all over again, step by step, to explain in more detail how it was built. So as an overview, what I did was break this effect down into a couple of steps. I knew I needed to fracture my geometry to have those pieces sort of peel away, and then for those pieces to generate trails behind them. So that's how I started thinking about it, and so I'll start with the fracture and the breakaway. Now I did this with just the SOP level RBD Bullet solver. What's driving these pieces is just a pop wind. That's pretty easy stuff. Like, there's no gravity in it. The wind just blows the pieces up. And how I got the sort of the animated peel off effect was by animating the active attribute across the fractured pieces. So for the fracture, it's really straightforward. It's just a Voronoi fracture sphere that I've given some thickness to, so that the pieces are contained. They're not like giant shards. And then I chose to use the Mops Falloff, some of the Mops Falloff tools to generate this spreading attribute. You can do it any way you'd like. This is just one way that was quick for me. So I literally just used the spread, the Mops Spread Falloff, animated the spread from top to bottom. I generated the falloff attribute from there, and then in a VOP, I just converted the falloff attribute that the Mops spread modifier gave me, and I converted it from a float to an integer, and that integer is the active attribute. That's what the bullet solver expects. So that's really quickly. That's how I got the pieces breaking away in that way. From there, I took the packed pieces, and what I needed to do was, these can't go on forever. I needed a way to scale those off over time. So this is actually an interesting bit. Even if you're really familiar with Houdini, a lot of users who've been in Houdini for quite a while don't dive into chops too much. I haven't that much either, but I found an interesting way of setting up more or less a countdown timer. So what I wanted to do was I wanted to generate an attribute that would continually count upwards from the time, say from the time that this piece. Let me see if I can just do a select. View only selected. Yeah. So from the time that piece becomes active, so you can see right here that right now it's not active, and then it is. I wanted to generate an attribute that would count up. So like for every frame or whatever, it would just give me a value counting up from the time that that active attribute changed from 0 to 1. And there's actually a chop. I guess these are a channel operator for that, and it's just called count, which is really useful. I've used it for a handful of different things, and so I've got this count operator in here, and then while this condition is on, I've got it set to increase the count. So let me see if it's going to show me. Yeah. So each one of these lines represents a single piece, and you can see when the active attribute switches over, and from that point it just continues to count up at a constant rate. And how I used that, and I'm going to go into detail on how to set that up when I build it, but how I used it was I brought that attribute back in, and then I remapped it. I used the simple vex to remap that value, and then I fed it into another Mops transform modifier, so that when that active attribute has been on for a number of frames, it starts to fade. It starts to scale down from 1 to 0 across a defined frame range that I set in this vex wrangle. So it may sound complicated. It's not really that complicated, but that's how I did that. And there's probably other ways to do it, but using the Mops modifiers to do this all unpacked geometry is really efficient, and it makes it really simple. It was really simple once I found out that I could sort of set that count timer inside of a chop net. And then the only other thing I did with these pieces, I have a secondary chop net that I wanted to have a little bit of life to these as they became active. I wanted them to kind of scale up a little bit, almost to give the surface this bubbly look. And that's all. And then I unpacked. Actually, I unpacked it before that secondary chop network, and then did a VDB from Polygons, and then a VDB smooth. And you can see already that we're getting this sort of, this sort of bubbly looking breakaway. But this doesn't address our need of the trails. So. But that's also easily enough achieved. If we come back to our bullet solver, this fourth output will give us just our simulation points. Let me turn off this template that I've inadvertently got on. So I've got my geometry. I've got my viewport display set to show disks for points, so I can visualize my pscale. So I've got my points here, and then I'll go into more detail about what's going on here. I'm just transferring that attribute, that countdown attribute that I have going on my pieces. I'm transferring that over to my points so that I can have those scale off as well, just at a different interval. So to get my trails, that's again easy enough. For each point in my sim, I just trailed that a number of times, and then in a for loop, I'll show you a single pass of that. There's one. So in a for loop, I used an attribute VOP to set the pscale based on the point number, because this is always from 0 to whatever. This is it's procedural. If I have more points, it's going to respond. So the 0th point is going to be the largest, and the other one, like the one with the highest number, is going to have the lowest pscale. And I'll talk about that more in depth. So I did that in a for loop so that I could isolate each of these groups and have the tapered trail work for each one. Because if I did this not in a for loop, the point order would be all over the place. This is again setting my scale off via that sort of active timer. So you can see my pscale is going to scale off as they get pretty far out. And then it was just a matter of using VDB tools, VDB from particles on this side, and then I combined the two streams, combined my the sort of the breakaway mesh and combine the trails, and then a few smoothing operations, and then convert to polygons, and that's the effect. There are some issues with the trails that are really close together getting, when I do this VDB smooth, they get all mushy. I don't mind that look. If that's something that you're trying to avoid, I did some experiments of doing VDB from particles and the meshing operations inside of this loop so that they're never together. But then the issue that came from that was that when I went to combine them with the original sphere mesh, I didn't get as smooth of a result. So I kept it this way. So again, that's about as fast as I can go through this process. So if you're happy with that, you can end the video here. And if you want to see more of a step-by-step detailed breakdown of this, just keep watching, and I'm gonna build this thing from scratch. Now I'm back up at my object level. I'm gonna turn off the geometry SOP that we just went through. I'm gonna create a new. I'm just gonna create a sphere. Actually, I'm gonna change this to a polygon mesh. Bring up my wireframe. I'm actually gonna change this to a polygon, and I'm gonna update. Give it a few more subdivisions and make it a little bit larger. Turn on my grid so I can see what I'm doing just a little bit. All right. So the first thing I need to do, knowing that, well, let me do this. First thing I need to do is scatter some points, because I want this to be fractured with the Voronoi fracture. And what this node expects is it wants your geometry to be fractured, and it also wants a number of seed points. To view what's going on with this, if you drop down an exploded view, you can see what's happening in there. And this is what I was getting at in the first bit. This is not what I want. This is treating this sphere as one solid chunk with it doesn't have a shell to it. So how I need to treat this to fix that is to drop down a poly extrude, and I'm just going to set this here in the viewport, just drag it out a little bit. I'm going to output my back. To visualize it, it's an easy way to visualize that is to drop down a clip node, and now you can see how thick you actually are pulling this out. Maybe not that far. That's probably fine. And now when we look at our exploded view, we have pieces rather than those huge shards. Now we've got too many pieces, I think. I think in my last example I did around 300 pieces. So I'm just going to leave it there. And you control the number of fractured pieces via these seed points, which is the scatter node. And for the fracture, that's all we need. To prepare this for the bullet solver, the SOP level bullet solver, we need to pack that geometry, to have packed primitives. You may be able to do that other ways. I tend to do it with an assemble, especially when it's coming out of Voronoi fracture, or if I have a lot of packed objects, I do an assemble. We need to tick on the create packed geometry, and that will pack each of those pieces up into a packed primitive represented by a single point. Now, in my last example, I used the Mops Spread Falloff SOP, and I think it's the easiest way to get this effect. There are multiple ways you can do it, and I think I'm going to in the file that I eventually share, I'll probably have some other ways of doing that and sort of embedded into the file. I'll probably show one other really easy way for people who might not have the Mops tool set. It's free. It's great to have, but I realize that some people are in studio situations where they can't install third-party things for one reason or another. So I'll show you a very easy way to keep moving with this without using this spread fall off. But for now, I'll also show you how to set it up. So I clicked on the fall off preview. And then I hit display as sprites. The sprites are far too large. What this is doing is it's just putting a circle sprite on every on every point. And the blue fall off, or the blue color, is the area with no fall off, and when it gets to white, that means it's going to have 100% fall off. We need to give it a group to start. I just chose a piece at the top. I just clicked on this arrow, chose a piece, hit enter. You can set this a more procedural way. You can set a group and then feed it that group. That's probably the more preferred way, but just moving pretty quickly, just grab a point and feed it in there. That's going to break. If I go back up here and change the number of points that are feeding into this, I'll have to reset this by selecting a point and hitting enter again. So just be aware of that. To get this to animate, what we're going to do is just spread that across. So we set a keyframe at frame 1, and then somewhere, wherever you want it, just set a second keyframe when this is fully on. And then at some point in the halfway, or around halfway of this transition, if you want to add noise to this, you can come into the noise tab and up the amplitude of that noise, just to give it a little bit more of a breakup it won't look like a solid line coming through your sphere, through your geometry. That's another reason I really like this. The Mops tool sets. It's just makes things like that really easy. Just that the noise is built in. You can remap your fall off to make it a little bit more harsh, which I've done here. I think I did in my setup as well. When you're done animating that, just undo the preview fall off. If you don't do that, those sprites are gonna ripple through everything that we do. Next, what I need to do is, so what this has done is it's given us it's given us an attribute called Mops Falloff that is going from 0 to 1. We see that here. And what we need from this, it's given us a float attribute for that. And we need to map that to an integer attribute called active. So I'm going to do that in an attribute Vop. You can do it in a wrangle, probably even quicker than this, but just to show you how to do it here, I'm going to do it in a Vop. So we need to bring in our Mops Falloff attribute. That's what was created. To do that, we use a bind node and we type in mops _ falloff. And so now we have our Mops Falloff attribute in our Vop network, and we're going to export. The way to export attributes out of a Vop is using a bind export. This is going to be called active, and we need to set this to integer. Now, I didn't just make this up. The active attribute is an attribute that's sort of built into the bullet solver, and when any piece that carries the active attribute has a value of 0, it's not going to react to any forces in your sim. And when that active attribute, when its value hits 1, it's going to sort of become active and start contributing to the sim. So that's where that came from. That's not just something I made up off the cuff. Now what I need to do is I need to do a float to integer conversion. This actually may not be necessary, but I did it anyway. And this is actually why I did this in Vops, because I don't know the vex command for that offhand, and I just sometimes when I'm breezing through setups, I don't want to dig through help cards and find the vex call. I just want to search for it and do it. So that's why I used that's why I did it in the Vop. I'm just going to call this fall off to active. All right. So I actually forgot to show the way to animate this attribute, this active attribute, not using the Mops Falloff. So real quickly, I'm going to do that. I'm going to create a group SOP. That group I'm going to set to points, and I'm going to set the group by keeping within the bounding regions, and I'm just going to make this wide enough to encompass that whole sphere. Bring it up, come to the first keyframe, or sorry, come to the first frame, set keyframes. I think it was down around 120. Oops, wrong one. Then just drag that down. Okay, and now what I'm doing is I'm basically animating a group, and then I'm going to do an attribute create. Call this active. Declare the attribute as active. It is going to be a point attribute, but it is going to be an integer attribute, and set the value to 1, and then I'm going to limit that to the group that I just created so that I have an active attribute. You can see it animating right here. So now I've got an active attribute that's coming on, but only through those groups. So that is how you can, if you don't have Mops installed, do this, and then just continue to go through the rest of the tutorial, and you should be good. So now we're ready for our bullet setup. So we can just use the RBD Bullet solver. It takes a minute to pop in. Feed our geometry in. You may ask why there's an error, and that's just because we're not on frame 1. Go back to frame 1, and we'll see that nothing's happening because I don't have it selected. So we'll see that as these pieces become active, they're just going to collapse. And I don't have a ground plane, I don't have anything in there. So what I want to do is, in the Forces tab, I want to set my gravity to 0, and inside the solver there, I want to put down a pop wind. This is really similar to using the SOP level vellum solver, how you add particle forces inside here. So I'm just setting the wind velocity to carry pieces upward, and I'm adding some noise to it as well. Let's see how that's going to look. Yeah, honestly, like for our purposes, that's just fine. This is just demonstrating how it's built. You can art direct this to your heart's content, but that's what I've got set up. So now we need to, I'm going to drop down a couple nulls, really just for organization. You don't have to do this. So I'm going to call this my pieces, and this is going to be my points. And I'm going to address the issues with the pieces first. So the main thing we need to do is to get these to scale off. So one thing I want to do is I want to give each of these points an ID. I'm gonna use it more later, but I just want to go ahead and do it now. So I used to create ID attributes in a wrangle just using the point number, but I've recently started using the enumerate SOP, because it does exactly what I need it to. This group type is going to be points, and I don't want it to be called index. I just want it to be called ID, and it is an integer. And now you can see I have an ID attribute that matches my point numbers. So I've got that set up. I will use that later. I'm going to come back to it. I know I'm going to need it, so I'll just go ahead and drop it down. Now I want to make an attribute create. And what I need for this is I'm not going to actually do any manipulations of this attribute. I'm just going to create it so that I can pull it into my ChopNet. You can call this anything you want. I just called it morph because this is what I'm going to use. That's the attribute that I'm going to use to scale down the pieces via that countdown timer. So I'm just going to call this morph attribute create. Another null. This is just going to be to chops 1. And now I'm going to need a chalk network, and then I will also need a channel SOP to bring that back in. I'm going to view this. And now the way that chalk networks work it's probably a bit confusing. So I'm not going to get very deep into it, but I'm just going to show you sort of how to set this up. We need to bring our geometry in from our SOP level. So in here we can just point to that null because we want to bring it in at the point in the network just before that. So 2 chops. That just references our it references this point in our network. And the scope of this, first off, this is animated. We want to do this over the course of our animation, not just at one point in time. And the attribute scope that I'm looking for is active, because what I want to do is I want to find everywhere that there's an active attribute. I want to do something to that, and I want to rename that scope morph. Okay, so the next thing we need to do is we need to call up this count operator. Now this is so handy, and I just recently found it. I've already used it for a number of things. And what we're going to do is we're going to tell this to whenever this attribute scope, whenever active, whenever that happens, while active is on, increase the count. And let's see if that's gonna do anything. You can see down in this readout, it's generating all these curves for us. And so we have it. So each piece, again, like each one of these lines is one of the points in our sim, and for each time that point hits the active attribute has a change in it, it's recognized here and it starts to count up. And that's exactly what we need. But now we have to call that new attribute that we're writing out, that morph attribute. We need to call that back into our network. So in this chop section, we can just drag our chop net in there and now tell it that we're bringing in an animated attribute. And for our channel scope, it's going to be morph, and the attribute scope is morph. Okay, and that's really all we need to do. Now, if we look down in our attribute spreadsheet, for anything, as these pieces become active, we get this morph attribute that's counting up. Now what do we do with that? So we just need to set up some parameters to set, say, when this morph attribute is maybe 15 or 20, we want it to start scaling down. So in between the value of maybe 15 or 20 and say 60 or 90, we want the scale of each of these pieces to go from 1 to 0. Now, again, we're going to use the Mops transform modifier. As soon as I'm done explaining how to use this Mops SOP to accomplish this, I will also show how to do this with standard Houdini nodes as well. So again, this is a transform modifier. What it is going to do is it's going to apply these transforms, whatever you set in here, it's going to apply these transforms anywhere that it finds this attribute on the points being from 0 to 1. So I want to change this to morph, because that's the attribute that we set here. So now this is going to scale things down at a uniform scale to 0 whenever the morph value is 1. So right now there's nothing happening because the morph's all 0. And now we're getting a ton of negative scales because the morph value is way up, 20 or so. So again, we're going to have to remap that value. The easiest way, this time, I felt like the easiest way was with a wrangle. I'm just going to call this morph remap. Call that whatever you'd like. So I'm going to pull in the at morph attribute, and I am going to say that morph equals a fit version of itself. So fit at morph. And here's where we're going to set our minimum and maximum frames. I'm going to start off with 15 to 60, and we're going to say that that is 0 to 1. Let me see if this works, and if it works, I will explain it in a bit better. Yeah, so now our pieces are scaling off. So for those who might need a better explanation than me just reading what I was typing. So the first side of this, we're calling in our, we're actually declaring this, attribute and saying this is what it's going to equal. So we're going to say that our morph attribute equals whatever the incoming morph attribute was, and we're using this fit function. And what the fit function does is it expects, so inside you type fit, and then inside these brackets, the first argument it wants is what are you fitting? And what I'm fitting is the incoming morph attribute. And then what it wants is the minimum value and the maximum value that you, current value, so the current minimum, the current maximum, and then the remapped minimum and the remapped maximum. So I'm saying that when that morph attribute is 15, have the fall off value that's feeding into this Mops transform modifier, have that be 0, and when it hits 60, that's 1. And again, the transform modifier, what that's expecting is a fall off value between 0 and 1, and anywhere the fall off value is 0, none of these transforms are being applied, and anywhere that value is 1, all of these transform values are being applied. So as our new morph attribute grows from 0 to 1, our scale is being applied from 1 to 0. Hopefully that makes sense. I think that's about as clear as I can explain it, especially in a relatively short video. All right, so I did remember that I had another dependency in here on Mops for scaling off these pieces. So I'm going to really quickly show you an alternate way using the primitive SOP to get this for those people who might not have Mops installed. I'm going to delete this just so I can show you what's happening. So I dropped down, I'll just do it all over again. I dropped down a primitive SOP, okay, and plug that in to this channel node where we're generating our morph attribute, because we're eventually gonna need that. So I've got my primitive SOP. I'm gonna click on in this transform tab, click do transform, and then in the scale, that will scale down our pieces from their own centroids, which is in this case is what we need. But I need to do it in a way that is being driven by that morph attribute. So what I did was I made a copy of this where we're remapping our morph, because with our fall off, as you know, we needed a fall off value that went from 0 to 1. Well, this is going to control our scale directly. So I want that to start out at 1 and then go to 0. I'm going to drop down a for each connected piece loop, and what that is going to do is generate a class attribute, and that's going to let me inside this loop do operations on any individual piece or all individual pieces. So now I'm going to snag this and put it in my loop, but I can't just animate this with keyframes. I need to call in the incoming morph value. Okay, so this, if you're not familiar with this may be a little bit weird. So what we need to do is use the point. This is H script. You need to use the point function. And what's nice about this is it gives you a ton of hints on how to use this and examples here, which is always helpful for me because I tend to forget some of the syntax. So we need to start with we type in point and then do parentheses, and then we need quotation marks, and we need to point to our surface node. Right here under this uses, it tells you point, call in your surface node, tell it what number, tell it the attribute, and tell it the index. Okay, so I'm going to walk through that. So I need to call in, using quotes, dot dot will call in the immediate network. I know that it's going to be one of the for each ones. I just don't remember which one. It's for each begin /2. All right, so for each begin 2. I've got that called in. Close your quotations, comma. Now I need my point number. Because I'm in a loop, that's always going to be 0 because there's only one point in the group, so the first point is always 0. Then I need to do quotations, bring in the attribute that I want to read, which is morph. And then, now if this is if this is a vector like position, you need to tell it which unit of the position to pull in. Do you want it to be the X, Y, or Z position? In this case, I only have 1, so I'm going to do 0, which defines the first, and then close my parentheses and apply. And I got something wrong. Let me see what I did wrong. It says it failed to cook. This needs to be for each begin, not for each end. All right, so I just called in the wrong surface node. All right, so now if I accept that, I'm good to go. And what's going to happen is that scales down. It's not scaling down uniformly yet because I only have this in the first dimension here. I've only got it in the X dimension. But you can see that that's doing what I want it to do. So now I'm just going to copy. Actually, if you click on this, it'll show you the expression. So select all, copy, paste for all 3 directions. And now let me tick off of the single pass. And now there we go. So we've got our pieces scaling off. And if you don't have mops, take this branch that we just made and then plug that into your unpack right here, and this will bypass these 2 nodes. All right. So the next thing we need to do is we need to unpack these, because again, these are packed primitives. Right now they're, if you look here in the spreadsheet, all we have is 1 point per piece of geometry, but as soon as we unpack these, we have, what am I doing? We've got point positions, we've got all kinds of stuff. And we've got many, many more points, like 9,400 versus probably 300 here. Okay, so now the reason I'm unpacking this is because I want to convert this to a VDB, and there was no geometry information right here to convert to VDB. It would just convert a single point. So let's do a VDB from Polygons. I'm going to set this down much lower, and that's really all I need. Once I merge these together with the trails, I'll do some smoothing operations to really blend them together. In my other example, I did another chop network that would sort of jiggle the scale of these a little bit. I'm actually going to just leave that out for this walkthrough. It's not super necessary. You'll be able to see it in the file that I post if you want to, or you can figure that out. It's really just it's doing the same operations in here, just in the secondary chop network, and rather than using the count chop, using the jiggle chop. So I'm just going to leave that out for now, just for the sake of time. And that takes care of our pieces. Now what we need to do next is to generate the trails from our points. So I think I mentioned this in the quick breakdown. I've got my points set up to be visualized as sprites. That'll give me an idea of the pscale that I'm working with. So I need another enumerate because I need IDs on these points as well. So I just copy that over because it's doing the same thing that I need. I'm going to need a trail sop. And what this is doing is it's giving me, at a certain increment, it's just making copies of the point at a previous time step. So I'm going to leave that. I don't want there to be a huge gap in it, so I'm condensing this trail increment down somewhere around 0.5. But I don't want a uniform pscale on these. What I want is that to be tapered. And the reason that I set up this ID attribute here primarily is so that I could separate, so I can work on these trail groups in a for loop. So let me just drop that down. So I'm going to do for each connected piece, but I actually don't need this connectivity sop. I'm going to pull this up here. Now, this is giving me errors for a number of reasons. This expects, when you drop it down, it expects to run over primitives. I want to run it over points. And it also expects a piece attribute of class. That's why that connectivity sop was there. But I have this attribute set up here for ID. And what happens here is each point that's generated, each point in the trail that's generated will inherit the ID of its original point. So I can use that to my advantage here and just run this loop over groups of these points. And to illustrate that, if you just use the single pass, if you click single pass on, that'll show you what's happening inside a single iteration of this loop rather than all of them simultaneously. So now what's nice about this is if I look at my point numbers, my original point is 0, and then it just counts up from there. So I can use this, and you can imagine just saying pscale equals point number and just do a fit or invert that somehow so that your highest pscale is so that your lowest point number is your highest pscale and your highest point number is your lowest. Again, I'm going to drop down an attribute vop, do this inside the loop. And the reason being because I want this to be procedural. So I want when there's 7, 8, 9, how many ever points, I want that to be recognized by my expressions in here, so that my distribution is smooth across all the points. So you probably picked up on it. What we need to do is we need to bind export pscale. That's the attribute that we're after. So I'm going to start there. And what I need to do is I need to fit my number of points, which is nicely given to us here. I need to do a fit range. Fit range of my my source maximum is going to be my number of points. My value is going to be my point number. So at point 0, the value is 0. At 6, the value is 6. And my minimum and maximum, I'm actually going to promote both of these, but I'm going to invert it. So because I want my leading point, the number 0, I want that to have the maximum value of, I want that to be the biggest, and I want the highest point value to be the lowest. So what's going on here, this number of points, if I change this to 10 points, then this is gonna remap my fit range to whatever the highest number of points is, and that's why I chose to do this in a VOP, because I get these for free and I don't necessarily know how to type that out in Vex, so I didn't want to fight it. I just got it. And then lastly, I want to do a ramp parameter. Because now I'm getting something out of here that's 0 to 1, but I want to have a little more control over that out here in my VOP. I want this to be a spline ramp. And when I did that, it looks like it went away. The reason being is this spline ramp just defaults to nothing. All right. So this is really what we need. You can leave it at this if you want and just control it with a ramp. I like to have my ramps to have more room in them than that. So what I'm also going to do, I already have it out here. My minimum value, I want that to be much lower. Or I'm sorry, my whatever the highest value is, I want it to be much lower. And my minimum value, I don't want it to be 0 either. There we go. And now I have a little bit more. I have a little bit nicer ramp to use rather than trying to deal with these like super small values. All right, so let's see what this is doing. Let me turn my point numbers off. Oh, and I'll show you this as well. So now that no matter where I go, if I put a ton of points in there, it's always going to have that smooth trail, or that smooth taper, which is what I was after. So this is pretty good, but there's a couple things that I need to fix. Let me turn off single pass so you'll be able to see it, and turn off my point numbers as well. Now I don't want these trails to be to have full pscale when they're not moving, and I also don't want them to live forever. I want them to scale off in a similar way that they did in the pieces. I want these trails to not always be present, but as they've been active for a number of frames, I want them to scale off, which we've already done. We just need to apply that over to our trails. But first, let's take care of the issue of them being at full scale when they're not moving. All right, so we're going to hop back inside this attribute block where we've got our pscale created. And what I'm going to do is I want to use a length bop. What this is going to do is this is going to measure the length of whatever vector is coming in. I'm going to measure the length of my velocity vector, because what that will do in essence is give me a speed. And what I want to do is I want to say that whenever that speed is 0, the pscale also is 0, and whenever that speed reaches 1, then that's my pscale is as high as it'll ever be. So I need a couple things to do that. One, I want to clamp this. Excuse me. I want to clamp this value at 1, but I know I'm going to want to fit this, because I don't know what my minimum or my maximum speed is going to be. So I'm going to just say, well, I guess my minimum speed is going to be 0 when they're not moving. I do know that. So if you middle click, promote parameter, it will give you this little bump out here. If you double click on that, it'll give you the option to rename this. So rather than source max, I'm going to say this. I'm going to call this speed max. So I'm going to put here speed max. And now what that's going to do when I hop up one level, it's going to label this so I'm not confusing myself. I should have done it with these, but I didn't. Those are those ones. So I'm going to take that. I actually want my clamp to come after this. So let me rewire this. I want I want my length. I want the length of that velocity to be fed into this fit range, and then I want that to be clamped. And then I want that to be a multiplier of this tapered pscale. And you can already see that that's doing it. So when we hop up, I'm going to have to dial this in a little bit, but when we hop up, we can see that these are coming alive and they're scaling up, and it's not that bad. It's actually working pretty well. Now, if I increase this maximum speed, all that's going to do is give me a longer fade up or a longer scale up from 0 to 1. So that takes care of the first part. Remember, we had two parts. One was I didn't want those trails to be present when they're not moving. We successfully addressed that. Now we need to deal with, as these have been active for a number of frames, we want them to scale off. And I mentioned we already did that. Like, we did it over here with this channel operator and this morph remap. There's no need to double our efforts since we already did it. What I'm going to do is use a attribute copy, and I'm going to drop it here so that my trailed particles will inherit this attribute. And what I'm going to get is this. this morph attribute that we're given, the countdown timer stuff. I'm going to pull that over here and copy that morph attribute, copy the morph attribute. I'm going to copy it via this. This is what makes attribute copy really nice. Is it says, how do you want to copy this over? Is there an attribute that we can match between these two sets? And there is. It's the ID. That's why we added this ID attribute over here to pieces. All right. So now we have our morph attribute copied all the way over here, and it's gonna ripple all the way through all the trails that we've made. And then again, I can copy this, which was my vex attribute, or my vex expression for scaling these down. And rather than @morph equals this, I'm just going to say @pscale. I always mistype that. @pscale is going to be, I think it's going to be times equal that morph. And I wanted to make sure that this is going to work, and then I will explain it in a moment. And it didn't work. Hang on one second. So the reason this didn't work was I have this backwards. I don't want my pscale to go from 0 to 1. I want this to go from 1 to 0 over these times. So now you can see that those fade off as they go. Now I don't want this, as it is now, this matches the exact frame range as my pieces going away. I don't really want that. Let me do a quick, this is just a temporary merge to sort of view what we've got. I don't want my pieces and my points to trail off at the exact same time. So I'm going to adjust this this timing. So I'm going to say, how about maybe from frame 30 to 120, or maybe even let's just do 90. And let's see how that's going to work. So now my pieces should fade away right around now, and then the trails last a bit longer, and then they're out as well. And for our purposes, that's fine. And again, I'm going to explain this just for clarity. So what I'm doing, we copied over this morph countdown timer business. We copied that over, and so in this vex expression, I'm saying, okay, so what I want is I want my pscale. So I'm saying, okay, @pscale, you are going to be whatever you already are. So if my pscale is already 1, it's going to be that's the times equal. So it's going to be whatever the value of pscale is times this value. Okay, so it's you could say that this times equal is a shorthand way of saying @pscale equals @pscale times this function. All right, it's just a shorthand way of writing it. So I'm saying my pscale is itself times a fit version of this morph attribute. Again, I hope that makes sense. And that's all we need to do really for the trails. Lastly, we're going to have to convert these to VDB. So we need a VDB from particles. Grab that. You're going to get an error because it's got this minimum radius. We're dealing with things that are pretty small, so I just set this minimum radius to 0 so it's not ignoring any particles. What I want to do is I want to copy this voxel size, copy parameter, paste relative reference. So now we're dealing with voxel grids that match. Now then, we're going to do a VDB combine. And what this is going to do is it's going to take these two different VDB grids and combine them into one grid based on what we tell it to. We want to do an SDF union. So now we've got all of our grids in one, and now we can start smoothing this. So if we use the VDB smooth SDF, what we're going to get is a is a nice blend. I chose to use the Gaussian smooth. It's a pretty aggressive smooth, but I think it works nice because what that's going to do is give me these really blobby shapes. What it may be doing, and it looks like it is it's smoothing it so aggressively that some of our trails are completely disappearing. So you can go back and you can do it a number of ways. You can do a VDB reshape. What we want to do is we want to add a little bit more volume to our trails. So that defaults to a dilate operation, which sort of like grows the voxels out a bit, grows that surface out a bit. That's one way of doing it. You can increase your point scale here. You could also increase your pscale, any number of ways that you'd like. You can increase your minimum or maximum, however you want to do it. You can adjust those trails any number of ways. But now what you see is we've got merged together. The pieces are merged along with the trails, and they're as the pieces scale out and the trails get a little bit bigger, it looks pretty seamless. And what I was really happy with was the breakaway of this. We're not quite finished. We need to do a VDB convert. We need to convert this to polygons. Let me turn off my wireframe here. I actually want to do another smooth. So when we convert this to VDB, we get some pretty noticeable faceting there. So let's try to do a smooth SDF here as well. And I'm also going to do this kind of aggressively. I'm just going to pull this down to 1, but change it to Gaussian, maybe even up to 2. Yeah, we're starting to lose some of our small pieces. We start to lose, but the faceting really goes away. And I don't want to do it too far down. I feel like that's much better than it was right there. And again, this is going to get smooth even one more time when we combine. So I think that's helped to get rid of some of that faceting. But we may have lost a bit too much of our pieces here. But let's see. This is looking kind of cool. It looks a bit different than the original one. Particularly when pieces come off, there's these big holes. That's because of the smoothing that we've got going on. I think what I want to do is just do a quick reshape SDF. I want to dilate this just a bit. I think that's going to help us out to preserve some of our volume. Yeah. And that's looking a lot better. I'm going to do a play blast. I'm going to look at a few more frames here and then just do a play blast of this to see what it's looking like. But even if this isn't the perfect execution of this, there's plenty of room to go back in here and tweak. At least you've seen a walkthrough of how it was built. Let me pause my recording and do a quick play blast of this, and we'll see what it looks like. All right, so here's the finished piece. There are probably some things that I would go back and tweak with it. I think some of the trails could stand to be longer and maybe not quite so tapered. But again, all the controls are built into it for you to go back and tweak that as much as you'd like. I hope this gives you an idea or a better grasp on a few things, how to set up effects like this. A couple things to maybe key back in on. That setting up that countdown timer, I think, is a really helpful bit of information for anyone who watched this. I also think keeping things simple. Like this is, I think with Houdini, even when people say something's simple, it can tend to get complicated pretty fast. But thinking about these effects in terms of it was really all soft level stuff. There was one DOP-net that was just, even that was a really simplified DOP-net for the RBD pieces. And then just really pushing the VDB tool set in Houdini to blend these pieces together to make things as smooth as you can. Understanding a little bit of how for loops work, and really just trying to think creatively with just knowing. I feel like even if you know just a little bit of Houdini, if you know a handful of SOP tools, you can really push a lot of effects pretty far. So I hope it was helpful. Thanks again so much for taking the time to watch this. Thanks for all the comments on the posts on Twitter. If you like it, feel free to subscribe. I'm going to try to put out more videos. These things are really time consuming. If you want to support me for the time that I put into these, check out the files on Gumroad. I'm going to put this file, a cleaned up version of this file, up for a few bucks if you want to pick that up and dive deeper, or if you want to you don't want to watch through the whole tutorial, you can just grab that file and learn from the file if you want to go that way. Just a quick note, like I tend to put the files up for relatively cheap, so I intend for them to be used as learning material. So just say that, but feel free to grab the file if you want. And if not, everything that's in the file is what we learned here. It's just a cleaned up version of it. So thanks again for watching.